We're going to find the equation of the tangent line to f of x at 1 over x minus 1 at x equals 3, and then the normal line to this function at x equals negative 5. The first thing that we're going to have to do is find an expression that gives the slope of the tangent line at any point for x. And so in order to do that, we're going to use the definition that gives us that. So that's going to be the limit as h approaches 0 of f of x plus h minus f of x over h. So limit as h approaches 0 of 1 over x plus h minus 1. The parentheses aren't really that necessary there. 1 over x minus 1 all over h. So now it just becomes a matter of simplifying this. So the limit as h approaches 0, what I'm going to do is I'm going to get a common denominator. And so the common denominator is x plus h minus 1 times x minus 1. So I'm going to get a common denominator for all three terms basically in this. So I have this term, I have this term, and I have this term. And if I think about the term in the denominator, I can really think about it as h over 1. Because all three of these things, I'm going to treat them like their own individual fractions. So I'm going to treat them like their own individual fractions and make sure that they all have this common denominator. So the first one right here needs to be multiplied top and bottom by x minus 1. So I have x minus 1 over x plus h minus 1 times x minus 1. I'm just going to call the common denominator b to make my life a little bit easier. Then subtract. I'm going to multiply the top and bottom, the numerator and denominator of this fraction, by x plus h minus 1. Then I have that denominator. And then this one is going to be h times everything that's missing. So x minus 1, x plus h minus 1. I should probably not write it like that. So x plus h minus 1, and then that's all over this b. Well, now since every single thing is over b, now what I can do is multiply the entire top and bottom by b, and that gets rid of the fractions. So I don't really need this step if I'm aware of what's happening. I'm just kind of going through all of the algebra. So all of these b's end up basically canceling out, so to speak. So you have x minus 1 minus x plus h minus 1 all over h times x minus 1 times x plus h minus 1. And what ends up happening anytime you do this definition is that the numerator should simplify so that anything that doesn't have an h in it should automatically cancel out. So the limit as h approaches 0, x minus x, those end up canceling out. -1 minus -1, or -1 plus 1 when you distribute, those end up canceling out. So now we are just left with minus h. So the numerator is minus h, and the denominator is h, x minus 1, x plus h minus 1. And now when I see all of this, I'm now left with an h in the numerator and denominator that are multiplied by everything that's left, so I can cancel them out. So now I am finally left with the limit as h approaches 0 of -1 over x minus 1 times x plus h minus 1. And now I can just directly substitute 0 in for h. And what I'm left with is -1 over x minus 1 times x minus 1, which is the same thing as -1 over x minus 1 squared. This right here is the expression That gives the slope of the tangent line at any point. Now, I'm going to find the slope in the equation of the tangent line at x equals 3. So my slope is -1 over 3 minus 1 squared. I just sub 3 in. So I get -1 over 2 squared, which is -1/4. The other thing that I need to do is I have to remember that f of x is 1 over x minus 1. So if I sub 3 in here, I end up with f of 3 is 1/2. So now I can write the equation of my tangent line. So the equation of my tangent line is y minus 1/2 equals -1/4 times x minus 3. I just plug this into point slope form. That's the x, that's the y, and this is the slope. For the normal line slope and equation, what I'm going to do, it's probably easier. Now I could find an expression for the slope of the normal by doing the opposite reciprocal. So the slope of the normal is x minus 1, the quantity squared. But what I'm going to do, just the way that I tend to think about it most often, is I just find the slope of the normal or the tangent line, and then I take the opposite reciprocal after that. But either way is fine. So if I sub in -5, I get -6 squared, which is 36. Or I could have done it from the tangent slope. So tangent slope is -1 over -5 minus 1 squared, which is -1/36. And then you can take the opposite reciprocal and get 36. So now that I know that, the other thing that I have to know is what f of -5 is in order to get my point. So f of -5 is -1/6. So the equation of the normal line is y plus 1/6, just using point slope form, y plus 1/6 equals 36 times x plus 5.